Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called the add two numbers. So this is basically we just need to add two numbers, but the only difference is this is linked list, right? So we have been given two linked lists and we need to add those and we need to return the output. So this is as simple as it is. The only thing they are mentioning here that digits are sorted in reverse order, but we don't need to worry about that whether it's in reverse order or not. The example we can see, like, it's just a simply just adding one by one every digit, right? So 5 and 2 7 and 4 and 6 10, so that is 0, and then that carry 1 will be there and that will be added to the next digit, so 4 and 3 7, and that one carry will be added to here, so this will be 8, right? So this is pretty straightforward. So what we can do here, we can just go over both the linked list, right? So and let's try to cover some of the cases as well, right? So let's say I am having these two linked lists, right? So 1 and 2, and let's say I am having 3 and 4 is as well, right? So if it is there, then we go one by one, this pointer and then this pointer, we add this, so output list will have 4, and then after traversing we go here and we go here, and then 4 and 2 6, right? So this 4 and 6, this will be our output list. Now let's consider about the scenario about the carryover as well. So carryover, we can easily carry over to the next part, right? Let's say this is 9, right? Or something else, 8 as well, whatever, right? So what will be the output in this case? 1 and 3 4, but 9 and 4, that will be 13, right? So 13, 3 will be here and 1 will still be there, so 1 we will be adding to the our output list after generating our, so 3 and then 1 as well. So we need to consider those cases as well, wherever the carry is still remaining hanging around, and then we need to add this to our output list, right? So that's one case. Other cases might be like if a list is having only one element or something like that, right? So these kind of the cases we need to cover when I'm taking one element, like say, let's say this is one only, right? And another other linked list, basically this is null or something, this is not having any value, right? Let's say this is null, so null and then 1, then output should also be null, right? So these kind of the test cases we need to come up with, and then we need to decide that what way we want to go forward. But this is pretty straightforward. We will just go every both of the list one by one, just keep adding though, and then basically we will be returning that to the output list, right? Here we can take whenever we are taking our output list, it's always a good idea to take some dummy linked list, basically assigning 0. And the advantage with that, basically we will be getting, because we don't need to take care of a lot of edge cases as well. So when I say edge cases, means like if list is null or list is having only one element or something, right? We will always have the dummy, that's 0 in our output list, and that dummy will be pointing to the actual list, so that we will know that we already have something that we can rely on. So that's why we need some dummy, and we need some pointer, right? So that we can at least point and we can rely on that pointer, because we don't know what input we will be getting. We might be getting null as well, right? And if we might be getting null as well, then we at least know with this dummy pointer, okay, this is my dummy pointer and this dummy pointer next is null, then it means something is not there, right? So that's why we take the dummy pointer. So let's try to create some of the placeholders and then let's go from there. Okay, so let's say list node, let's create some dummy here, and let's say this is 0, and let's take and the current pointer as well, that will point to the dummy. Why we need current pointer? So that we can just start our traversing and we can just start getting the result in the current pointer, right? And then let's go ahead and then just traverse these both the list here. So while, and then let's say if L1 is not equal to null, right, or L2 is not equal to null, right? And why we are using or here? Because one list can be pretty long, one list can be shorter as well, so we want to make sure that we are adding both the list, right? And that's why we want to make sure that both the list we are considering. So if I do the AND here itself, right, then what will happen in that case? If one list is pretty big and another list is another one list is pretty small and another list is pretty big, right? Let's say it's having 5 and 7 on the second list, then in that case I will be adding 1 and 9 with 3 and 4, but I will be these 5 7 I will be ignoring, right? So this will still be there, but I did not add in my looping. So that's why I'm taking OR, so that I can consider uh, both the additions. So let's say my first element is like, if L1 is not equals to null, then go ahead and take this value, otherwise it will be 0. Let's say int b equals to L2 is not equals to null, then let's take this value, and then this is 0, right? Now let's go ahead and sum these guys, a plus b, and let's take some carry as well, because if it is more than 10, sum is more than 10 or more than 9, then it will be some carry, right? So let's go ahead and add this as well, carry. Now let's say dummy node and this current node, right? So let's go ahead and add current dot next. Why current dot next? Because the current is pointing to the dummy, and dummy is having already the 0 value, so that's why we want to assign it to the next. So next means zeros next, dummies next, right? And this will be some mod 10. Why we are doing mod 10? This is like simple addition, so I'm not doing something special here, some mod by 10. So for example, like 1 and 3, and if I mod by 10, then it will be 4, right? 9 and 4, this 13, and if I mod by 10, then I will get 3. So always mod by 10 will give me the last digit, so that's what I wanted to add here, right? And I need to calculate the carry as well. So carry will be always sum by 10. So every time I am just carrying, so let's say 9 and 4 is 13, and 13 by 10 I will be getting the carry. How much carry I will be getting? I will be getting 1, right? So 13 by 10 I will be getting 1, so 1 will be carry forward to the next addition, right? So in this case, if it is 1, then this 1 will be added to this 5 here, and this will be 6 in the next addition. So that's the idea. So now let's go ahead and forward this current equals to current dot next as well, right? And that's pretty much it. That's it. And in the end, let's go ahead and return this dummy dot next, right? So dummy dot next will have the actual result that we already built. Another case we need to take care, like if it was 9 and 4, as I earlier mentioned, let's say this is 5 and 7 is not here, and this having 1 9 and 3 4, and adding 9 and 4 will result in 3, and still one carry is still there, so we need to still add the carry at the last, right? So we can take care that case as well. So let's say if carry is still not 0, then go ahead and add that as well, right? So current dot next in that case will be new list node carry. And yeah, I mean that's pretty much it. So let's quickly see for the compilation error, and let's see if there is any compilation related problem. If it is not there, I think we should be good to go. So time limit exceeded. Okay, that's okay, but let's see. Okay, so time limit exceeded because we are not going forward with our L1 and L2 that we should do. If we don't do, then we are really not traversing, right? So this L1 and L2, they should also move forward. So L1 equals to L1 dot next, similarly for L2 as well. So if we don't do that, then we will be at the same point. So if we see here 1 and 3, once we add these, we need to move forward to this pointer to the 9. Similarly, we need to move this pointer as well, considering they are not null, right? Otherwise we will get null pointer exception. So L2 equals to L2 dot null, and this will also be the L2. I think time limit should go away now, but let's just verify. Okay, so that's pretty cool. Let's try to quickly analyze time complexity and space complexity as well. So time complexity will be order of n. Let's say it will be like because we are traversing, let's say these are having n elements and they are also having the n elements, but with the help of we are going basically 2 pointers. Basically 2 pointers means we are already having these list node, right? So we are just going we are just going basically every node at one time, right? So here it's 1 and then 9, and then similarly we are just moving 3 and 4 as well, right? So I will say whatever the maximum linked list will be there, that will be the complexity, but if we are calculating the approx complexity, that will be the linear complexity, right? And the space complexity would be 1, order of 1, because we are not taking any additional space. This is just a pointer, but we are not maintaining any array or anything, so this will be order of n, right? And time complexity, as I mentioned, if you have to exactly tell, then this will be the uh, max of m comma n. So let's say I'm one list is having the m size, m nodes, and another size is having n nodes, then it will be the maximum. Whoever is having the maximum length, that will be my complexity, that will dominate other, because at least I have to iterate the longest list, right? So let's quickly try to submit this one as well, and let's see. Okay, so this is working as we planned, and hopefully it all made sense. Another quick optimization we can also do, so we are checking it here, carry is not equals to 0, right? So what we can do, if we don't need this additional line, right? So what we can do, we can quickly optimize and refactor our code, and we can just add it here as well. So let's say if carry is not equals to 0, then also we can take care of the same thing, right? We don't need to maintain it separately. That's one refactoring we can do. So if carry is not equals to 0, then it will still run through this loop, and then it will be adding. But yeah, the earlier code, it makes more sense, and it's more intuitive, but it really depends upon the personal choice how do we want to handle. But yeah, let's quickly try to run this as well, and let's try to submit this as well if it is working fine. So this is also working fine. So this is one refactor we can do if we want. Thanks a lot. Bye.